Okay. So you have your colored pencils, your highlighters, whatever you do. All right. We have domain and range. I'm going to go green for domain. So domain, as we have stated, is a set of all your x values for which the function is defined, and those are also known as your inputs. Oh, you ahead of time. Your range, I'll go pink. My range is a set of all my y values, and those are the outputs. So after you plug a domain in, you're going to get the output out. Put your phone away, please. And this foldable is going to have some different ways to show you, and you should be able to pull stuff from some are easier ways than others. So the first way is from a mapping. So this right here is called a mapping, if you recall. This is a mapping, and we can clearly see that our domains are on the left. So if someone said, what's the domain of this function? You would simply say -1, 0, 1, 2, and 3. Those are our domains, correct? And you can use this little set. So when you do the set of them, you got to use the curly brackets. So you would say that the domain is -1, 0, 1, 2, 3, and we put them in order from least to greatest, and this is our domain, right? Super easy to pull from a mapping. Our range. Our range, these are the values here. Super easy to pull. That's a little loud. If we want to do the range, same thing. We use the set brackets. When it's a set, you got to use the curly brackets, even if you don't like drawing them. Suffer through it. So the range of this set, starting smallest to largest, is 3, 5, 11, and 21. So that's the domain and range that we could simply see right there. If you have repeats, you do not have to write repeats over and over. So if you have a couple 3s in the range, you only have to write it once when you state the range. Sometimes they'll give them to you in points. If they gave you points instead, like ordered pairs, so they can give you points. Can someone give me the ordered pairs that they see in this mapping? What's the first ordered pair you see? -1, 5, 0, 3, 1, 5, 2, 11, and 3, 21. So they might not give you this, and they might give you this instead, but you can still pull out your domains and ranges from this, correct? I'm just going to color code them. So green for my domain. So these are my domains right here. And I'll do pink for my ranges, and those are right here. Super easy to pull from points. They might also give you a graph instead. So maybe they'll give you a graph. I'm not going to put all these points on here. Let's just put a couple of them on just so we have an example. So they could just give you the points of like -1, 5, 0, 3, 1, 5, and so on. They could give you points on a graph, and you could still find the domain and range, correct? Just label the points, pull them out, or see where they are on the XY axis. But giving a mapping or ordered pairs or a graph, super easy to pull out domain and range, right? Those are discrete points. Yes? Questions on those 3 ways? Okay, so let's look at a graph next. And basically the only way you can write your answer is in this like set notation, because it's just going to be just numbers, comma, another number, comma, another number. It's not going to be like continuous and going on forever and ever. Okay, so let's see what it looks like from a graph. Okay, so here's a graph. Does anyone remember what kind of function this thing is? T is a square root function. So this is a square root function. And what's true about a square root function? Where is he going to go? He's going to go positive forever. So he's going to go forever to the right and forever up, correct? You don't see him doing it, but he will do that. Does he come forever backwards or down? No, he starts right at 0, 0. And 0, 0 is included, right? So we could basically put a dot and fill it in right there, because 0, 0 is included. That is where the graph starts. And then he goes up to positive infinity and to the right to positive infinity forever, with no holes or gaps or anything. I didn't do that. You're going to run out. And you're going to miss this stuff. Is it an emergency? Okay. All right. Okay, so when we talk about, let's do the domain first. Domain. Domain is which axis? Okay, so I'm talking about domain here in green. So I want to know where this graph lives on the x-axis. So does the graph live back here anywhere? No. So if I'm coming out here, you agree he's not back here. Where does he start coming into existence? At 0, 0. And then does he keep existing? Is he still existing? Forever and ever. If I keep walking to the right forever, he is going to keep going out here. Yes? So he starts at 0 and he goes forever that way. Okay, so that means our domain. Let's talk about some ways to write it. Our domain starts at 0, you said. So probably the way you learned it first in Algebra 1 was all the values x that are greater or equal to 0, correct? That's one way to write it. That's the easiest way that you figured out how to write it first, okay? All the x's that are greater or equal to 0. Boom, over to the right. That's one way to write it. The next way to write it is in set notation. So that means you have to start with the set brackets. So draw the set brackets. And we're going to start with the x's. And then we're going to draw a bar. This bar means you read this such that. So let's put this fancy term. This means such that. You'll sound official and fancy. So all x's such that x is greater or equal to 0. And that's fine to write it like that. So when I look at this, I would say something like, it's the set of all real x's such that x is greater or equal to 0. And that tells somebody it's all the x's in the whole wide world that are 0 or bigger, right? Another way to write it is as a compound inequality, which means you have to have the x in the middle. And remember how you have the smallest on this side and the biggest on this side with the x in the middle? So it's going to look like this, similar. So I've got all my x's such that, and I put the x in the middle this time. What is the lowest x can be? Don't fall asleep. You're going to be confused. 0. Is 0 included? So we do the less than or equal to sign. And then how far does it go? Infinity. So we do less than infinity. And you can do plain infinity or positive infinity. Plain infinity and positive infinity mean the same thing, just like plain 7 and positive 7 mean the same thing. And then close your sets. All of these things mean the same thing. I'm going to show you one more way, which is the way I love because it's the easiest. The last one is interval notation. And all you do is pick your lowest and your highest. So what's your lowest? 0. What's the highest? Infinity. So you do 0, comma, infinity. And you need to have either round brackets or square brackets around it. So let's put a little note what each of them mean. So the round bracket means that it is not included. The square bracket means that it is included. So put a little note for yourself. The round bracket means not included. The square bracket means included. Okay, so did you write that? Okay, so let's decide. Is the 0 included? Yes. So what do I need by him? Square bracket. Is infinity a real thing? Can you grab him and tell me where he is? No. So that way we automatically use the round one for infinity. So if it was not included or if it's infinity, we use the round one. Question? I don't know. Squiggly, what do you mean? That means the set. So when you see squigglies, you're saying the set of all x's such that x is in between them. So this is set notation. When you have the squigglies, set notation. This is interval notation. So it's saying it's from here to here. You see how we can't do interval notation when we had those points on the last problem? Because it wasn't like a solid range of from here to here. You know what I mean? Okay, that is all the ways to write domain. Okay, let's do range. So I'm going to do range in pink. So you told me range was the y's, correct? So range is the y's. So I'll talk about range over here. Okay, so where does this graph live on the y-axis? Up and down. Does he live down here? He's not down here at all. When does he start living? He starts living at 0 and he goes up forever. Do you guys agree? Okay, so he's not down here. So what is his lowest point? His lowest point is 0. Is 0 included? Yeah, and it goes forever. So we can say something like our range is y's greater or equal to 0. We can also use f of x, like f of x is greater or equal to 0. We know that those mean the same thing. Y and f of x are the same z's. We don't have greater, he doesn't live down here. There's no graph down here. He starts here and goes up there. If this came down here, then yeah, we would start way down wherever he started. Or we might even, if he starts forever down there, we might be starting at negative infinity. Okay, can someone give it to me in interval notation? What do you guys think this would look like in interval notation? What's the smallest? The smallest is 0. I don't know what this sheet is right here. The smallest is 0. And what's the biggest it goes? Infinity. So you can write positive infinity or just infinity, same thing. Now we need to see if we need round or square on either side. So what is 0 included? So what do we write on that side? Square. Is infinity included? Yes. You can't even tell me where he is. No. So then no. Because he's not like an official spot, right? Infinity is just can't even stand it. Who wants to make an attempt at doing it in set notation? What do I have to start by writing? You need those funky brackets. We can start with y or f of x, whatever you y, such that line. You can do, okay, we'll do a compound inequality, 0. It's always going to be less than. It's always going to be, they're always going to be pointing this way. Less than or equal to. They look like the L, remember? Y less than infinity. Close your little set bracket. Do you have to write all these ways every single time? No, but you might see them in different ways. You've got to know what they are. I love interval notation, and that's probably what shows up mostly in all your classes. That will be in the future. It is just like the bar, kind of like an absolute value. Did you finish? Did you pass? Yay. Everyone clap for her. She passed her test. She gets a graduation seal. Okay, and there's some, they have some examples down there of different ways to write it. Also, a graduation, you know how you need a certain number of seals for your graduation? You can earn them for different stuff. And I will, are you going to a class right now? Yeah. Which class? Okay. Okay, write down some ideas in pencils, what you think about this one. And I will email your second. Yeah. I don't know. I think you need chemistry first. Forensic science. Okay. Domain and range. So let's do domain. What color did I do domain in? Green. Okay, green. We're back on. Okay, so we want to talk about how far left and how far right. Where does this graph live? Now let's talk about the end behavior of this graph. For realsies, it needs to be zipped up because you're about to get a referral. Because literally, it's been like 4 times. I know words are hard sometimes. Okay, so what does this graph do on this end? Down and up. So it's going down and out forever. What about on that side? What's the end behavior? It is also down and out forever. So remember that although you might not see that the graph is up here, please know he's going to keep going down and out forever, right? So on this axis, you see what he looks like. He keeps getting wider and wider and wider and wider until the end of time. Make sense? He never ends. He never stops getting wide, and he never stops going down. Does he go up? No. He does have a top boundary, doesn't he? Okay, so let's talk about domain first. If he goes forever left and forever right, which you said he does down here, then what is our domain? What's the lowest point he goes to down there? Negative infinity. What's the highest point he goes to on the other side? Positive. So his domain of this guy is going to be negative infinity to positive infinity, correct? Isn't it? Because it's going to keep coming out here, negative infinity to positive infinity. Do I need square or round brackets around that? Both round. Both round. Remember, you always start with the lowest, like you guys told me here, left to right. So you're always starting with the low. So make sure you do the negative infinity first to positive infinity second. Another way to write that is you learned the all real numbers. So you could say all real numbers. Because it's all real numbers in the whole wide world, right? Positive infinity, negative infinity, all real numbers. Do you remember the symbol for all real numbers? It's like a capital R, except they kind of do a double line. So make a capital R, but make two lines like that, and then make your R. So if you see an R looking like that, that means all real numbers. And people love that because it's nice and quick to write. And a lot of graphs have all real numbers. Like if you think of any line in the whole world, won't it go forever both ways? So the domain of all real of almost all linear, unless they're going straight up and down, is forever, right? Let's just write down that way this time. We won't try the other. We won't do every single notation for every single problem. Okay, let's talk about range. Range. Range is going up and down on the y-axis. Does it go forever up? Does it go forever down? So it does go forever down. So we do know it's going down to negative infinity, correct? But it has a top point. Where is the top point at? So the highest point is right here, correct? We don't care about how far back it is. This is the very top, right? So think of the very top. He never goes above 1, does he? Okay, so let's do the range. I'll put it up here. You guys have some space underneath it, but sometimes when I write it underneath here, you guys can't see it when you're in the back. So I'll do the range over here. So what is the lowest point of my range? What? What'd you say? It's negative infinity. That's my lowest. What is the highest point? Comma, 1. It goes from down here, boom, boom. Never goes above 1. So my highest point is 1. Lowest is negative infinity forever. Highest point is 1. Okay, do we put squares or around brackets around these guys? What do we put on this side? Round, because the infinity is always round. What about the 1 is? The 1 included. Does it touch it? Yeah, so it is going to be square. You're right. Square. Okay, good for domain and range of that guy. The next one we'll do in set notation. Okay. Well, we got to practice all of them. Okay. Tell me about this guy. What kind of graph is this one? He is exponential. Yes. He's exponential. Tell me about exponential graphs. They curve. They come down here. Now remember there was a word on our vocab, this asymptote. That means that this graph, there's an invisible line. Ooh, that's weird. There is this invisible asymptote that this graph comes down close to, but never ever crosses. It's kind of like a plane coming in for a landing who never actually lands. He just stays and gets closer and closer to the ground, closer forever. He never touches it. He just gets so close, closer, closer, closer. Imagine that. And your head will blow up. But it's possible to keep getting closer to something and never touch it. This close. Okay, so he's coming close. What is this asymptote? What level is this that he's never going to go below? He's never going to go below 0. So this is at 0. So he's never going to go below x equals 0. That's where this is, right? Never going to go below x equals 0. so let's talk about his. But he does keep going this way, right? What happens to him on the left side of the graph? He goes up. What else does he keep going? And left. He's going forever. So it looks like he's mostly going up, but he never stops coming this way either. He's just going to keep coming up and up. So he's going to go forever this way and forever up. Forever up and forever to the left. Okay, so let's talk about domain. Let's go domain. Now domain is on this x-axis. So where do you think what's his furthest left point? How far does he go over here? Infinity. Doesn't he keep going this way? You said he does. What about the other way? Infinity. So that means his domain is what? Negative infinity to positive infinity, which is all real numbers, right? But we're going to use set notation. Okay, let's use set notation. So that means we have to start with a set. Start with your set. I'm going to do it in black because it's kind of... Okay, start with your set. And these are x's we speak of, right? So put an x such that, and all your x's such that x, now we say he's got to be real numbers, right? So we can say x is an element of real numbers, and we do that like this. Look at this symbol. It looks like a C with a line in it, but it's curved. And then your big fat back R, fat back, it's like a double back R, fat back R. So this means element of. So when you read this is saying the set of all x's such that x is an element of the real numbers. Fancy? Fancy pants, right? Okay, so this was our domain. Okay, let's do range. Range is where? Range is up and down, right? Okay, so how low does this graph go? Does it? No. I thought we said there's this invisible line that it doesn't cross over. So what is the lowest it goes? Except it doesn't touch 0, right? So it comes close to 0, never ever touching 0. So it's going to be close to 0, never ever touching. And then how high does it go? Infinite. Okay, so we're going to try to do this in set notation. We might answer your question, so just wait 1 second. Okay, so let's try to do the range in set notation. So what do I need to start with? Little bracky poo-poos? Okay, what do I write next? We can write y or f of x. Let's go f of x because we haven't used him for a while. Let's write f of x because we know f of x is the same as y. All f of x's such that, what do we want f of x to be? How can we write all of the stuff in the world that's bigger than 0? We can just do the greater than. We can say all f of x is such that f of x is greater than 0. Would that be all the numbers from here higher? That would work. We don't even need to use the compound inequality if we don't want. That's cool. What was your question?
I was going to ask if, since the line never crosses 0, could you say that?
Okay, are you good? Now that's not, obviously we could have done interval notation like we did over here, but we're practicing writing different ways, so that way we can do different ways. That's all right, I'm scrolling. Take a picture of it. Beep, 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 beep. Okay, this guy. I'm going to show you what he looks like on Desmos so we can make a quick sketch. So it says to graph this function, and we want the values of x such that x is greater than 0. Describe the range. So we only need the range. Okay, so I graphed him for you on Desmos. Let's make a quick sketch. This is what he looks like on Desmos. I'll punch these points for you. I'll make it bigger. Okay, make a quick sketch because I'm going to flip the screen. Make a quick sketch, bless you. So he looks like he crosses the y-axis at 0, 4, and he is his minimum vertex is at negative 0.5, 3.75. Make a sketch because I'm not leaving the screen up here. Okay, everyone have a quick sketch? Okay, so it looked like he he crossed here and his vertex was there. It kind of looked like that. Now we know that these graphs keep coming up and out forever, right? Okay, so we wanted to describe the range. Now we only want the values for x. Box that up. So what does that mean? We want the values of x such that x is greater or equal to 0. So this is my x-axis. So where's the side that's greater or equal to 0? The right side, which means we don't want anything on the left side. Okay, so get your highlighter, whatever you do, and get rid of this entire side. You are not going to use this side at all. So don't even look at it because it says you only want x greater than 0. So you're only looking at this side. All the left side is gone. Bam. Gone. This is gone. Nothing over there. Don't look at me. Hideous. Okay. So that means up here. I'm not looking at it up here either, am I? Okay, gone. That means I'm only looking at this little piece over here. Okay, so we want to know what the range of that is. So what is the range? So the range is on this axis, right? So what is the very lowest point where he lives? 4. Does everyone agree? He lives right here at 4. And then where does he go then? Up to forever, right? Up and right. But we don't really care about the right because we're only doing range. But he does go up forever and right forever. Okay, so that means how are we going to do our domain? Which notation do you want to use? The simple one? Okay, so what's the lowest? 4, comma, what's the highest? Infinity. Do I need square brackets or round brackets? Square at the 4 because 4 is included, right? And then round at the positive infinity. Good? Okay, scrolling. A little review of Algebra 1. What does the closed circle mean? Included. Closed circle is included, and that's when we use which bracket? Square bracket, right? Open means what? Open means not included. And that means we're going to be using the round bracket, right? And you did those when you did those little number lines and filled in the circle and you had donuts or not. Remember when you made little graphs and you had to have the circle with the thing, and that meant it was not included. Remember, greater than. Okay. So look at this graph. What is going to be my domain? Domain is going to be left to right. What is the furthest left it goes? Is that the furthest left it goes? No. Does it go back here? No. Okay, so this is the furthest left. So we're going to start at -1. And where does it go to? Infinity, because look, that goes forever this way and that way, right? So to positive infinity or just infinity, do I need squares or do I need it? It's a whole. A whole means not included, so what do I need? We need the round, and we need the round. Because it does. Because open means not included. Whole is open, right? All right, range. How far up and down? Where's my lowest? Down here is my lowest. I'm hearing my range starts down at -3. Is -3 included? No, it's a whole. Comma. How far up does it go? Positive infinity. What do I need here? Round. And we're going to glue. Let's glue. We won't try to speak the last one. Glue on page 80. You can tuck your purple paper right inside of it. Glue, open the glue. For the love of God, open the glue right now. Stop losing papers because you're too lazy to smash that paper on glue. 80. Page 80.